Hey, have you ever stopped to think about what a Rubik's Cube, a pair of dice, and maybe some building blocks all have in common? It might surprise you, but the answer is actually a really cool math concept. And in this explainer, we're going to dive right in and unlock the secrets of what we call cube numbers.
Yeah, on the surface, it seems like a pretty random question, right? But the connection between all these things, it's all about three dimensions. You've got length, width, and height. And when those three things are exactly the same, boom, you get a perfect cube. And believe it or not, there's a special kind of number that goes right along with it. And that brings us right to the main event. What is a cube number anyway? Let's break it down, because this special kind of number is, quite literally, building the world all around us. Okay, so here's the simplest way to think about it. A cube number is what you get when you take a whole number, multiply it by itself, and then you do it one more time. That's it. It's like a number on a little multiplication adventure, 3 steps long. Let's try it with an easy one, the number 2. Okay, so first, we multiply it by itself. 2 times 2 gives us 4. Easy enough. Now, we take that result, 4, and multiply it by our original number, 2, one more time. So 4 times 2 is 8. And just like that, you found one. 8 is a cube number. You'll also hear these called perfect cubes, and honestly, that name is a huge clue. Why perfect? Because these are the numbers that can form a perfect, solid 3D cube. No gaps, no leftover bits, just a perfect shape where the length, the width, and the height are all exactly the same. All right, so how do we actually find any cube number we want? Well, it's a super simple 3-step process. Let's walk through it together. Okay, let's try it with the number 3. Step 1, you take 3 and multiply it by itself. So 3 times 3, that's 9. Now, for step 2, you take that answer, 9, and multiply it by our original number, which was 3. So 9 times 3 is 27. And that's it. The cube of 3 is 27. See? Not so bad. Now, to save us from writing 3 times 3 times 3 over and over again, math has this awesome shortcut for us, an exponent. See that little 3 floating up there? That little guy is just a quick way of saying multiply the big number by itself 3 times. So we don't say 3 with a little 3. We say 3 cubed. It's way faster. Okay, now for the really cool part. This is where it all clicks. We're going to connect these numbers to actual physical shapes. This is the aha moment where the name cube number is going to make perfect sense.
Remember our cube number 8? Well, imagine you have 8 little building blocks. With those 8 blocks, you can build a perfect little cube that's 2 blocks long, 2 blocks wide, and 2 blocks high. A perfect 2 by 2 by 2 cube. Now try doing that with 7 blocks or 9 blocks. You can't. It just won't work. Only 8 makes that perfect shape.
And the exact same idea works for 27. If you have 27 blocks, you can build a perfect 3 by 3 by 3 cube. It's amazing, right? In a very real way, the number is the shape. So this idea has a name in geometry. It's called volume. The amount of space something takes up. And guess what the formula for the volume of a cube is? It's the side length, which we'll call S, multiplied by itself 3 times. Hey, that looks familiar. It's S cubed, the exact same thing we've been doing. And this is where it all connects back to the real world. So if you have a little box where each side is 3 centimeters long, its volume isn't 9. Nope. Its volume is 3 cubed, which is 27 cubic centimeters. That abstract number we found, 27, perfectly describes a real physical space. Okay, now that we get the idea, let's become cube spotters. I promise. Once you know what to look for, you'll start seeing this math concept hiding in plain sight everywhere. Think about it. The cube shape is a favorite for a reason. It's super stable, it's easy to stack, it's predictable. You see it in the dice you roll for a board game, the ice cube tray in your freezer, those building blocks we talked about, even a perfectly wrapped gift box. They are all physical examples of a perfect cube. All right, to make sure this is all super clear, let's just run through a few common questions and share some cool facts you might not know. Okay, this is a big one. People mix up square numbers and cube numbers all the time. The easiest way to remember the difference is to think about dimensions. A square number, like 3 times 3 is 9, makes a flat 2D square. But a cube number, like 3 times 3 times 3 is 27, builds a solid 3D cube. So it's basically the difference between a picture on a page and an object you can hold. Here are a few neat little patterns for you. If you cube an even number, the answer is always even. If you cube an odd number, the answer is always odd. Simple enough, but the most mind-blowing thing is how fast these numbers get huge. This is what we call exponential growth, and it's why a box that's just a little bit bigger can hold so much more stuff. So here's a handy little chart with the first 5 perfect cubes. Honestly, knowing these can be just as useful as knowing your multiplication tables. Look at that jump from 4 cubed, which is 64, all the way to 5 cubed, which is 125. That's the power of cubing right there. So what do you think the next one is? 6 cubed?
So we figured out how to cube a number, right? How to build it up from its side length. But what about going the other way? If we start with the big number, like 27, how do we work backward to find that one single number that built it? Well, that process is called finding the cube root. And that, my friends, is a story for our next explainer.